Hello, Sally. This is Mr. Gibson, and I got your email about the worksheets for 2.6 and 2.7. And I know that you mainly have questions on section 2.7's worksheet. So let me expand this. I did take the liberty of actually doing the problems, but I'm going to go through and explain what I did. And then you would see how we would get the answer for C. Okay, so now the first thing in A. We need to do A in order to be able to do C. Now, we have here where it says with A, we have T. It says let T equals the year since 1950. Complete the table for T. Okay, so we look at the years here and we go since 1950. That'll be the 0 year. 51 will be the first year. 67, that's 17 years away from 1950 and so on. All of these are since 1950. Now there is one thing that I didn't do here, but the years is fine. It's just the debt in billions because it asks you here to round to the nearest billion, but we'll take care of that. Okay, so all of this, these are in billions or trillions. So we have to change these to be written in billions. So it says write it to the nearest billion. Now the billions place is here at this 257. So we look to the digit to the right of that, and if it's five or more, we'll add one. Four or less, we'll leave it the same. So basically, this would be 257 billion. Then with the 255, there's a 2 there, so it'd be 255. And the 326, there's a 2 there, so that'd be 326. And then here, now we get to the 4 digits, which takes us to trillions. The next digit behind this place value here is a 2. And then here, the next place value after here is a 1. And then here, it's a 2. And then finally here, it's a 0. So these are all the values we're working with. Now, we have to come over here to this table, and we're going to put these values in this table. Now, just in case you don't remember how to do a table, all you have to do is press the plus sign on Desmos and go down the table. And then it will create you the table. And then you will fill in the amounts. Now here, I put the years correctly. The only thing I didn't do correctly was I was supposed to do this to the nearest billion. So let me get rid of these decimal values real quick so we can get right to this graph. And what they were trying to do when they asked you to go to the billions place in the since 1950, they were trying to make this a little easier for you. Okay, so now this is our X value, this is our Y value. Now, I'm going to expand Desmos. Okay, if you look here, now first of all, on your Desmos, you may not see these points, but there's a little wrench here that you could click. And then you could go here to the x-axis. Now with the x-axis, you notice your lowest value is 0 and your highest value is 68. So you can make the x-axis, just to show you how to do it, you can make that 0 and then go, instead of going to 68, let's just go to 80. And that will cover all of your x values. Okay, now your y values, it goes from 257 to 21,516. So what we could do for our y values, we could just do our y values starting from, let's say, 200 all the way up to, let's say, 21,005, let's say 21,600. Okay, now you can roll your mouse so you can roll it in, and as you see here, you see all these points. So you could press the minus sign and it would show the points here. Now, of course, looking at this graph, it looks as though this graph is actually exponential regression, but we still have to check this. So what we're going to do, we're going to do an exponential regression, we're going to do a linear regression. And this is how you do it. I'm going to show it all on this screen here. So let's do the linear regression first. Okay, first of all, I didn't need to pick that. That was a mistake. Okay, now, first of all, the linear equation we know is y equals mx plus b. But what we're going to do here is, since this is y1, instead of y, we'll put y1. And then we have to use what is called the tilde. So you hit the keyboard here, hit the ABC, and hit this tilde symbol here. And then we'll do mx, and then 1, because we know our x is x1, and then plus b. So we typed out the general y equals mx plus b. So we got the linear equation. Now we're going to do the exponential equation. The exponential equation is like what you put in your email. It'll be y equals ab to the x power. But remember, it'll be y1. We'll still do the tilde. And then it'll be ab. And then we have to take this to the exponent. We'll hit the a to the b power. And then it'll be to the x1 power. And then after you do that, you have to hit log mode. You have to hit log mode. Okay, so now this is what we do. Now we don't just look at the picture and say, okay, well, this looks more like an exponential regression than it does the linear regression. No, we look here at our R value. Whichever one has the highest R value is the best line. And it looks as though the exponential regression has the higher R value. So the next thing we're supposed to do, they ask us to write down the equation. Now, according to this here, we would have y, oh, you know what, it'd be better if I type it over here in Desmos because it doesn't show up as well on here. So it'll be y is equal to, and then they ask us here to round to 2 decimal places. Remember, y is ab to the x power. So a, it says the 2 decimal places would be 188.38. Then we would do our parenthesis. And we know our b here would be 1.07. Close our parenthesis. And then we would take this to the x power. So this would be the equation that you would use. I don't know if I could copy this. Let's see if I could copy this. No, I didn't. It didn't show up right. But this is what you would have wrote down for C here. Now, that was one of your questions. Your second question was number 2, and you asked about 2A. Okay, it says the number of architects employed in Indiana since 2007 is listed in the table below. Okay. X years since 2007. This reflects since 2007. So that'll be 0, 2, 4, and 6. Now they have the number of architects, which we see here. Now it tells us to find a linear and exponential model for the data. Basically, we're going to be doing the same thing we just did. But what I would suggest that you do not get rid of 2 and 3. Because if you notice, this is already in slope-intercept form or linear form, and this is an exponential form. The only thing you need to change is this table. So you will click here, and then you will start erasing this until you get here. Now your y1 would be 1460. Then your x1 would be 2, 4, and then 6. And then we will finish up the Y ones. We had 1280, 1010, and we have 950. All right. Now, we typed in these values. Now we could take a look at the linear and exponential equation because we already had the linear formula and the exponential formula in here. So they want us to write both. They didn't ask us which was the better one. So here, with the linear, you would write y is equal to, the slope is negative 90. So it'd be negative 90x plus the b is 1,445. Now, one thing I didn't read, I didn't see, it didn't say how many places to round. So we're going to assume that it'd be 2 decimal places like we did in the last problem. So now this is the linear. Now we want the exponential regression. So we'll do y is equal to, and we know it's ab to the x. A is 1,454.85. We'll do our parenthesis. And then our b, we'll round to 2 decimal places, which would be 0.93. Close our parenthesis. And then we would take this to the x power. And that will be our exponential. This is the linear. This is the exponential. And we're done. Don't worry about what the graph looks like. This is correct. So that is basically it from the 2 questions you have. If you have any other questions, feel free to reach out to me. Thank you.